Now here at the beginning, I want to talk about periodic table, extra notes, this part, nuclear charge versus nuclear shielding. Okay, so here we write across a period and down the group. So when we have down the group, we have more and more shells. When we down the group, we have more and more shells, more and more barrier. In this case, we will call nuclear shielding increase. When you go down to the group, you have more and more shells, more and more barrier. So the nuclear shielding like barrier is going to be increased when you go down. Because of that, your attraction is going to be small. That makes sense. When you go down to the group, you have more and more shell. Then of course your attraction is going to be lower and lower, decreasing. That makes sense. Now, on the other hand, across the period, you have more and more proton, you have more and more electron. But when you go across, you have more and more proton to pull the electron closer and closer and closer. Now, this is called nuclear charge. Nuclear charge is talking about the difference between proton and electron. Now, when you go across, you have more and more proton, more and more electron. This will be called nuclear charge increasing when you go across a period. So when you put the electron closer and closer, the attraction is going to go up. So overall, I draw the trend. I say overall, attraction is going to go down, down, down the group. Then across will be increasing, increasing. So the overall trend for attraction will be the black line will be like that. Attraction, the line will be like that. Small to big, the black line. This is attraction. We're going to use this concept in a lot of stuff like radius and IE and EN. All right, so let's put this away. So we're going to talk about today notes. Right. So first, the atomic radius, I only read this worksheet is this video. So I tell everybody that atomic radius, the definition is on Weebly, and there's a picture included. Basically, atomic radius is half the distance from the nucleus of one atom to the other. So if there are two atoms, the nucleus is in the middle. The distance between the two nucleus divided by 2 will be the atomic radius. That's the definition for atomic radius. So the distance between the two nucleus and you divide it by 2 will be atomic radius. And now, again, we talk about down the group. Okay, so what happens down the group? You will have more and more shells, just like what we say here. Like what we say here, you have more and more shells. Okay, so when you go down to the group, you have more and more shells. So then what will be in charge? Will be shielding increasing. So nuclear shielding will be in charge down the group because it's barriers. So nuclear shielding is going up. You have more and more shells. The attractions go down. When the attraction go down, I cannot attract you that much. Then your size is going to be bigger and bigger. I think it makes sense because when you go down to the group, you have a lot more shells. Then your attraction is going to be less and less. Then of course the size will be bigger. Just like imagine you draw a bow diagram. The more shells you draw, the more size it is. Now across a period, right, we just talk about we have more and more proton to pull the electron closer. So in this case will be the charge take place. The charge is talking about proton and electron. So the nuclear charge will be increasing across a period. So then the valence electron is going to come closer and closer and closer. So then you have more and more attraction, then the size will be smaller. So what I tell everybody is you want to imagine when you go down to the group, attractions come down, and then attraction across the period will be increasing. So if you look at this picture, atomic radius will be increasing down the group, and decrease across the period. Okay, and the bottom of the element is bigger than the top element, and the right side element will be smaller than the left side element. That will be atomic radius. So we combine with increasing down the group, decreasing down the period, across the period. So we draw this trend, increasing down the group, decrease across the period. So we write this again, small to big, big to small. So then we can generate trend is from small to big, small to big, small to big. That's why we come up with this trend. Okay? Now we do the same thing is which one's going to be biggest atomic radius, which one's going to be smallest atomic radius. So we did one question, we draw the trend. When you go down to the group, you got to be bigger and bigger size. So we draw the trend, and then the bigger size on the bottom and the right hand side is small would be on the other side. So we arrange MG, CA, and S. So we arrange them. Now which one's biggest radius? That means which one is near to the big side would be CA. So CA is the biggest. Okay. And then this question was similar to what we did before. Now, ionic radius, I also tell everybody that the definition and the picture is on Weebly. Now, ionic radius is the distance from the nucleus to the valence levels of the electron in an ion. So if you draw a bow diagram, this is the nucleus, and this is the X is the valence electron on the shell. So the distance between the nucleus and the valence electron level will be the ionic radius. Now, the same thing, really like very same thing to the atomic radius is when you go down to the group, you have more and more shells, the shielding will be increasing. You have more and more shells, will be less lens attraction, then your size will be bigger. And when you go across the period, you have more and more proton, so then the nuclear charge will be increasing, you have more and more proton. So then the electron become closer, attraction is going to be higher and higher, so the size will be smaller. Because the valence electron come closer and closer, so the size will be smaller. Now here, I'm going to talk about 2 points is the metals want to lose electron. Because metal want to lose electron, you got to lose the outside shell too. Outside electron gone, outside shell is gone. So then they will form cation, and then we'll have the smaller size. So cation will be smaller size. Non-metal, they want to gain electron. And non-metal want to gain electron, actually the electron will repel in the same shell. They did not change the number of shells, but the electron will be repelling, make the electron and electron distance bigger. So they form anion, so then anion actually have bigger size. So if you look at this picture, this is group 1, 2, 13, 14, 15, 16, 17. Now group 1, 2, and 13, they form cation. Group 14, they can form both anion and cation because they can both gain or lose. And 15, 16, 17, they form anion. So you can see that ionic radius basically increase down the group and basically decrease across the period. So what happened is if you look up the cation, it looks like they decrease across the period. Across the period, decrease. And then when you suddenly go to like, after group 14, you go to 15, it become really big. And then when you continue to go to 17, they will become decreasing again. So ionic radius have the format, it's like down the group will be bigger and bigger. And then when you go across, it will be big to small, big to small. Suddenly, you get really big and get small. Now, the bottom element will have bigger size than the top one. And the right side, if you're talking about this, the right side is actually basically smaller than the right-hand side, than the left-hand side. The right side is smaller than the left-hand side in general. So in general, this is like anion. Anion will be bigger than cation. Now, you will find out that in ionic radius there will be no group 18 because noble gas don't form ions. They don't have ionic radius at all. So if you combine what we learned here, when you go down to the group, it's increasing and increasing. When you go across, cation is decrease. And then suddenly you become bigger size anion. That's why I draw the bigger arrow, bigger size, bigger arrow, then negative, and they become decreasing. And then we can follow through, increasing small to big. Here, the cation is from big to small because decreasing from big to small. And then suddenly, after I pass through the group 14, it will become really big, and then it starts to get small again for anion. So overall, when you go down, it's getting bigger, and cation will be smaller than anion in general, but they still have followed through the trend is big to small, okay? So then here, this is the same thing as before. You only compare cation, you only compare anion. So in this case, your trend will be same thing as atomic radius. So you can ignore the chart for this worksheet. You just arrange them same thing as the atom. But of course, you have to put the chart in the trend. So for example, here, I have negative charge, but I only have negative charge. I don't have positive, I don't have atom. So I just arrange them increasing, okay, from increasing to be small to big, and then we put the elements on that. Don't forget the charge, and because increasing order, we got to go from small to big. So it will be F minus smaller than O2 minus smaller than N3 minus smaller than P3 minus. So in this worksheet, you are going to arrange